Hello, I'm here to talk to you and give you a solution overview about the HPC Ready Architecture for AI and data analytics. What I want to do today is break down the solution components for you. In this architecture, what we're doing is we're taking a building block approach, and so what we have here is multiple building blocks where we start from a server perspective, network perspective, storage, and then as well as a software stack that we integrate into the architecture. Let's start with the server architecture first. If you look at what we're trying to do with the HPC Ready Architecture for AI and data analytics, we're trying to enable you to run 3 different workloads on the same architecture. And so what we have in here is we feature 3 different PowerEdge servers. One example is we have an R740XD that acts as our management node. So this management node runs essentially all the cluster. This is where you would run your Bright software or essentially our open source Ansible playbooks. On top of that, we have essentially what we call a utility 2U2 socket, essentially R740XD, that acts as an all-purpose compute node. Now, the reason this acts as an all-purpose compute node is the R740XD actually gives you the ability to essentially run V100s for deep learning training jobs. You have T4s to run machine learning jobs, and then you also have the capability to run FPGAs in the system that allow you to do essentially deep learning inferencing as well. We also have a C4140 that we offer in the architecture. This is a 1U 4 GPU dense compute platform that actually offers NVLink performance. So if you need the utmost performance for essentially deep learning training jobs for like image recognition or object detection, this is a perfect platform for that. And then last but not least, we have a DSS 84040 platform. And what this platform enables you to do is a for you concept. But what we're able to do with this platform is we're actually able to not only run V100 GPUs, we're also able to run T4 and as well as graph core IPUs in this solution. So when you look at the DSS 84040, this gives you a really good test development box to run multiple workloads if you're not sure which technology you need to use. On top of that, what we also do is we offer 2 different choices on network architecture. For those HPC customers that love InfiniBand and that's what they want to stick with, we have an all InfiniBand architecture where we allow you to run all these jobs in InfiniBand. For those customers that say, I'm not actually bought into InfiniBand and I still run Ethernet, we also have a 25 gig or essentially 100 gig Ethernet option as well, so you can choose your network options. And then from a storage perspective, what we do is we enable you to run different storage platforms. If you're already wanting to run the enterprise platform and essentially introduce Isilon into your infrastructure, Isilon provides NFS storage with essentially all the enterprise features from snapshots, backups, and all sorts of utilities there. On top of that, if you're looking for scale-out dense architecture as far as storage, we also offer solutions from BGFS and PICStore. Now let's get into the software stack because this is a really important component to what we do in our architecture. So we actually offer 2 software stacks. We offer an enterprise software supported version with Bright and essentially Bright Data Science, and then we offer a open source version where we've created a set of Ansible and Terraform playbooks where we essentially build Kubernetes and Docker environments for you if you don't want to pay for the Bright license. Now, the reason that this Kubernetes and Docker environment are so key to this architecture is that gives you the ability to essentially move these different workloads around. And by using Kubernetes and Docker, you have the ability to spin up and spin down these resources based on the workload need. And the reason that this is also important is that as we look at our architecture in the future and as we wanted to address different ecosystem tools, now what we're able to do is easily add those software tools if they're built on Kubernetes and Docker. As long as we're on the same version of Kubernetes and Docker and we can pass that Helm chart over from that software to our architecture, then we can actually validate that software will run efficiently on our architecture. And so when you look at this components here, we focus on server, we focus on network, we focus on storage, but not only that, we also have a robust software package that we build with that. With these Ansible playbooks, we're actually able to build an environment for you within 30 minutes. This integrates Kubernetes dashboard. This allows you to not only monitor your Kubernetes environment, but you can also manage, monitor, maintain CPU usage, memory usage, your pods, and so on. And then not only that, what we also do is make sure that we essentially give you Jupyter Hub notebooks so that the data scientist can get up on and running quickly. And you can use that Jupyter Hub whether he wants to do essentially Python and R in the programming language, whether he wants to use frameworks like TensorFlow or Horvath, or if he wants to spin up workloads like Spark. We all give you the ability within our software architecture. So in summary, if you're looking at essentially a architecture that allows you to run 3 different workloads on the same pool of resources, the ability to use a Slurm job scheduler, as well as to use open source tools like Kubernetes and Docker and Helm charts, we've built that into our architecture. So if you'd like to learn more about our building block approach and this modular architecture, please visit delltechnologies.com/HPC or delltechnologies.com/Ready Architectures to learn more.